In this video, I'm going to explain the problem with fast reattack tuning. Rapid reattack tuning is fundamentally problematic and inaccurate. It takes signal processing analysis to explain why. The first figure is a time domain or oscilloscope view of the note C6, whose fundamental is roughly 1055 hertz. It shows 9 attacks in 3 seconds, or 3 attacks per second. Let's listen. I'm using MATLAB signal processing models of extremely high order and high resolution to be used in this example, allowing way more spectral resolution than available ETDs could provide. The mathematical model of this system equivalently is that of a 3 Hz square wave, that's the reattack rate, modulating the note. This modulation will result in a modulation side lobes of the desired signal spaced 3 Hz apart. The signal processing window of time, delta t, in most ETDs would usually be somewhere between 250 and 750 milliseconds. In this next figure, we see the spectral smearing of the center, the desired fundamental frequency of 1055 hertz, which indeed is the tallest spectral peak in the spectrum, but is less than 1 dB above its nearest spectral neighbors. Notice the spectral neighbors are only 3 hertz apart because the repetition rate of the tuner who is striking the note is striking it at 3 times per second. Notice that the spread between the 3 highest peaks is 9 cents. The standard deviation is 2.7 cents. All known ETDs would likely be smearing these peaks in their spectral analysis and unable to resolve. The time domain needle of the ETD would likely be jittering somewhere near that standard deviation spread of around 2 cents. If it has good bandwidth to capture the signal. If the needle of the ETD is less than that deviation, it likely has insufficient bandwidth. The first objection I got to these slides as I tested them out with a friend who is an experienced piano tuner was, well, Steve, I don't put that much space between my notes. I go bing, 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 bing. I let them keep ringing. And I said, well, to myself, I'm a pianist. I know how to reattack very fast using professional piano technique. So let me record a sequence of very fast repetitions as a pianist would. And so then I'm going to look at that anatomy of the liftoff time, the dampening time, and the reattack time. And this slide shows it. So what I got was that the liftoff of the finger to the point where it's well damped with the damper coming down is roughly 40 milliseconds. And then the action comes up when you reattack, and that window is about 50 milliseconds. So that whole round trip, I call it, is 90 milliseconds. Let's just call it 100 milliseconds, a tenth of a second. So I went back into MATLAB and looked at the same kind of analysis I just showed, with longer dwell times, shorter distances in time between the repetition of the note. And it really didn't make any difference because the modulation is still that of a 3 Hz square wave, and you still get the side lobes, so that doesn't help.